Have you ever just, you know, looked at your hand or the phone you're holding? It all feels so solid, so real. But what is it actually made of? Today, we're going to peel back the curtain on reality itself. It's one of those huge questions, right? Sounds simple, but the answer? Well, it takes us on this incredible journey. We're going to break down everything around us, from the air we're breathing to the chair you're sitting on, just to find out what the basic ingredients really are. And to do that, we have to shrink down. I mean, way, way down. We're about to zoom right past anything our eyes can see, to find the absolute smallest little pieces that build, well, everything. Okay, so let's start with something we all know. It turns out most of the stuff we deal with every day isn't one single thing. Nope, it's actually a jumble of different substances that are all just kind of hanging out together. This is what we call a mixture, and it's pretty much exactly what it sounds like. You take a couple of things, you put them together, and that's it. There's no big chemical change. Think about a salad. A tomato is still a tomato, right? The chickpeas are still chickpeas. They're just sharing a bowl. It's the same thing with the air we breathe. It's just a bunch of different gases all mixed up. Now, mixtures can be a little sneaky. Sometimes they're super obvious, like that salad. You can see all the different bits. Scientists have a fancy word for that, heterogeneous. But other times, mixtures hide in plain sight. You know, like when you stir sugar into water, it just disappears. That's a homogeneous mixture, because it's so perfectly blended, you can't see the parts. But here's the thing, it's still just a mix. The sugar and water are just really, really close friends.
But what happens when things go beyond just mixing? What if they actually bond together? This, right here, is where things get really cool. And to see the difference, let's check out a super simple experiment.
So picture this. We take some gray metallic iron filings and some bright yellow sulfur powder. For sample A, we literally just stir them together. You can still see all the little gray and yellow specks. But for sample B, we take that same mix and we heat it up a lot. It starts to glow, and once it cools down, what we're left with is this solid, completely black chunk. Same ingredients, but whoa, two totally different results. And now for the moment of truth. We're going to bring in a simple magnet to test both our samples. Any guesses what's going to happen? And here it is. When we bring the magnet to sample A, the iron filings leap right out of the sulfur. Of course they do. The iron is still iron, it's just mixed in. But when we bring that same magnet to sample B, nothing. Absolutely nothing happens. It's like the magnet doesn't even see the iron anymore. The iron isn't just mixed, it's been transformed. That new black stuff is a compound. In this case, it's called iron sulfide. And this is the key. When things chemically bond, they become something totally new, with brand new properties. The iron isn't magnetic anymore because, well, it's not just iron anymore. It's part of a new team now. I mean, just look at the difference. In the mixture, everything kept its own identity, right? We could even pull it apart with a magnet. But in the compound, a whole new substance was created. It's chemically locked together and you can't just separate it. One is a crowd, the other is a family. Okay, so mixtures are made of different substances, and some of those substances are compounds. But what are the compounds themselves made of? What are these fundamental things that do the bonding? To find out, we're going to deconstruct one of the most famous compounds on the planet, water. So scientists can do this incredible thing called electrolysis. Basically, they run an electric current through water, and it literally tears the water molecules apart. You can see it happen. Bubbles of gas start forming and collecting in these test tubes. We're watching the chemical bond break in real time.
And what we get is just, it's mind-blowing. The two gases we collect are hydrogen and oxygen. Now stop and think about that for a second. We start with water, the thing we use to put out fires. We break it apart, and what do we get? We get hydrogen, which is a fuel, and oxygen, which fire needs to burn. The compound has totally different properties than its parts. It's like magic.
And those things, the hydrogen, the oxygen, that's what we call elements. We finally hit bedrock. An element is a pure substance you just can't break down any further by chemical means. These are the Lego bricks of the entire universe.
So how many of these universal Lego bricks are there? Just 118. That's it. That is the complete set everything. In the cosmos, from the farthest star to the tip of your nose, is built from some combination of these 118 fundamental pieces. That's the entire recipe book for reality.
All right, quick detour. We need to talk about a word we all use, pure.
because in science, it has a very, very specific meaning. See, when you're at the grocery store, pure just means nothing gross was added to it. But to a scientist, pure means it's made of only one single type of particle. So a bar of pure gold? Yep, that's a pure substance because it's all gold atoms. But get this, a glass of pure water is also a pure substance because it's all H2O molecules. As long as it's not a mixture, it's pure. So, elements, compounds, mixtures, why should we care? Why does any of this actually matter in our daily lives? Well, because understanding these basic categories is the secret key to building the modern world. Seriously, this knowledge lets us do amazing things. Chemists can design brand new compounds to create medicines. Material scientists can create special mixtures called alloys, like stainless steel, which is way stronger and more rust-resistant than just plain iron. And that phone in your pocket, the screen, the battery, the chip, it's all possible because we figured out how to combine and control more than 45 different elements to build it. And we're not done yet, not even close. This stuff is called graphene aerogel. It is made from a single element, carbon, just arranged in a really clever way. It is so ridiculously light that a piece of it can rest on a blade of grass without bending it. And it could be used for everything from cleaning up oil spills to making super efficient batteries. So next time you look around at the water in your glass, the metal of your car, the very air you're breathing, remember what you're really looking at. It's a fantastic dance of elements, compounds, and mixtures. You have the blueprint now. So what are you going to see differently?